Hello guys, I'm Paul McWhorter and I am here with lesson number 8 on using Python with Arduino, and hopefully you have been in on our first 7 lessons and this will be a continuation of what you've learned. What we're trying to do in this lesson is that we're trying to get to the point, we already know how to stream data from the Arduino to Python and read that data from the Arduino into Python in real time. And we know how to create 3D visuals, to create really neat visuals and graphics to relay that information. And what we're working on now is trying to get some graphing capability so that we can graph live data coming from the Arduino into Python and then sort of have like almost oscilloscope, like real-time graphs and charts of that data coming in. And in order to do that, we need to use the library Matplotlib. And what we did in lesson number 7 is we figured out and we installed that. And so if you have not installed Matplotlib yet, you need to go back to Python with Arduino lesson number 7. You get that at toptechboy.com. You come to using Python with Arduino, you come down to lesson 7 and you install that library. It's very easy, but you need to install Matplotlib. And also you need the NumPy. You need the NumPy library, and we downloaded that in lesson 2, and that downloads with when you download VPython. So go to lesson 2, download VPython according to those instructions. Go to lesson 7 and download Matplotlib, and then you will be ready to go. Now, before we start charting live data coming from the Arduino, we need to pause and just kind of familiarize ourselves with Matplotlib. And so this lesson is going to be about graphing data with that program. And what I want you to do is just kind of get comfortable with the parameters and comfortable using the program where you can graph things, and then we'll come in lesson number 9 and we'll start actually doing the live stream coming from our Arduino circuit. So what I need you to do is remember that that integrated development environment that we downloaded in lesson 2 that is called Vital for VPython. Okay, even though we're not using, even though we're just pretty much using Python here, this is a nice environment to use, and so this is the one I use. So we call it up, and we're going to start writing programs, and we're going to start seeing how to use graphs, do graphing in Python. So the first thing we need is we need NumPy. We need to load that library. Like I say, you should have downloaded that in lesson 2 when you installed VPython. NumPy comes with it, so we're going to import NumPy, and we're going to import it as NP. And this way, when we're kind of creating like an object NP, and that way when we go in and start doing functions, it's just easy to put np.this or np.that. It's just a nice short little way to import it. And also a lot of times, a lot of the examples you see, NumPy is imported as NP. We also need the Matplotlib, and we need .pyplot. And we want to import that as PLT. Again, PLT is kind of the standard. That way there's a lot of simple commands that you can use. All right, so we've got our 2 libraries in, and now what we are ready to do is we are ready to create a plot. So to create a plot, let's just start with the very simplest way that you can do it. You got to have a list of the x values, and you got to have a list of the y values. And so let's think of the line like y is equal to 2x. And so we need to create an array, and we will call the array x. And x is equal to show that we're doing an array in Python, we put an open bracket, and then we put the numbers in. So I'm going to say 1, 2, 3, 4, 5. Okay, so there is an array. All right, there is an array x. All right. In fact, let's run this. Okay. Okay. So what if I say print x? Okay. You see, I can sort of do things line by line here in the shell. So you see how we said x was that? I say x, it's that. What if I say print x of 0? The first element in x, that's 1. Okay, so because we start counting at 0, so the 0th element is the first element is 1. And so what if I say print x of, let's say 4? That'd be the 5th one, so that should be 5. Okay, so you see we have an array in there, and the array is like a list 1, 2, 3, 4, 5, and we can individually address those if we want. Let's have an array y. And if we want y to be equal to 2x, well, the first one would be 1 times 2 would be 2. It'd be 4. It'd be 6. It'd be 8. And it'd be 10. Okay. And so now we have two arrays. Let's run that. Okay. Look at that. What if I say print x, there's x, print y, there's y. So I got my arrays in. It's working. We're doing good. Okay. Now, if I want to plot something, what I need to do is say plt. Why plt? Because that's sort of what I named the object when I imported that library, plt.plot. And what do I want to plot? Well, I want to plot x. And I like to put white spaces in here. X and y. Okay. And let's just see if we can just say plot x and y. And then what I need to do is just say plt.show. So you always got to tell it to show if you want the thing to come up. And so I'm going to come up and run it. And boom, look at that. I got my plot. I got my plot. And look at that. If I have 3, it's 6. So this is the graph of the point 1, 2, 3, 4, 5 on x's, and y is 2, 4, 6, 8, 10. So it's like the point 1, 2, the point 2, 4, the point 3, 6, the point 4, 8, and the point 5, 10. And so that shows you with just a couple of commands you can start plotting data. Pretty fancy. Okay. What if we wanted to make it a little bit more, a little bit more custom? Well, you saw that just had a line. I can kind of control things by telling it the symbol I want and what color. And so let's say I wanted a red and I wanted a line. So I would say red, and then the dash mark should plot a red line. Okay. Look at that. I got a red line. Okay. I got a red line, just what I wanted. And how did I get the red line? Red dash. What if I wanted a dotted line? Well, I put red dash dash. Okay, and let's run that. Boom, a dotted line. Okay, let's try something else. What if I wanted a blue dot? I would say blue, and then the O, B, and a little O will be blue dots. Let's try. Look at that. I plotted those points that I entered there as blue dots. What if I wanted blue dots and a red line? Well, I could come in and do another plot, .plot. I still want to plot x. I still want to plot x. And I still want to plot y. But this time, I want blue dots. And what I want is, go away, you aggravating thing. Okay, I want blue dots and I want a red line. Okay, so I have blue dots, I have a red line, and now I should get both of those. Let's see what happens. Boom! I've got blue dots, I've got a red line, I've got everything just the way I want it. Okay, so you see, just with a couple of commands here, we're getting some pretty powerful plotting going. What if I want to customize a little bit? Let's add a title to our plot. So I'm going to say plot.p. I'm going to say plot dot title, T-I-T-L-E. Okay, and now I tell it the title, my line graph. Okay, my great line graph, because this is a good, really great line graph. So I'm going to say run. Boom. I got a title on my chart, my line graph, by using plt.title. What if I want, let's get this back, a label on my x-axis and a label on my y-axis? Let's add those. I'm going to say plt dot x label, and I'm going to call that my x-axis. Okay, and then I'm going to say plot y label, and I'm going to say my y label is my y label was 2. I'm going to just kind of make it so they'll see what I'm plotting. Y is equal to 2, and then I'm going to say times x. So I just sort of give them a clue as to what we're plotting here. And now let's try it. We should have labels on here. Look at that. Look at that. Okay, my x-axis, and I have y is equal to 2 times x, my great line. So you see how we're getting a lot of power to do plotting here with some real simple commands. One of the things I like I like, on my graphs, I think it makes it easier if you have a grid. Okay, so I'm going to put a grid on here. plt.grid, plt.grid, set it to true. And when we do that, it should put a grid, and I think it makes the plots look much more professional. All right, so what did we do there? Okay, you see this background grid? Now that is a pretty slick looking graph. And you see, just with simple commands, we have a whole lot of power to create graphs that we want. Okay, I really like that. I really like that. Let's see, what else can we do here? So we've added the grid, we've added the Y label, the X label, the plot title. What if we wanted to plot more than one line? Well, what if we wanted to plot 2x plus, what if we want to plot minus 2x plus 8, minus 2x plus 4, okay, minus 2x plus 4. Z, we're going to say, is minus 2x, so that would be minus 2 times 1. Okay, minus 2 plus 4 would be 2. Okay, and then the slope is minus 2, so we're going to go down 2 every time. So we're going to go 0, okay, and then we're going to go minus 2, and then we're going to go minus 4, and then we're going to go minus 8. So that is 2 times x. What is that? That's 2 times x. Just ignore that for a second. Let's go 2x. Let's go minus 2x plus 4. Minus 2x plus 4. So this would be minus 2 plus 4 would be 2. Minus 2x plus 4 would be 0. Minus 2x plus 4 would be minus 2. We would have minus 4, and we would have minus 6. And I'm sorry I had a little brain glitch there, but I think that that is minus 2x plus 4. So now let's run that. Oh, and now what we got to do is we got to plot z. Okay, so I plotted x and y. I plotted x and y. This time I want to plot .plot. And this time we're plotting what? We're plotting x and z. All right. And what I think I want this time is I am going to want a green line, a green dotted line. Let's just do a green dotted line. And then besides the green dotted line, plt.plot, let's say that I want x and z. And so I'm plotting, this was a dotted line, and now besides the dotted line, I'm going to print it. Still is green, okay? But let's print, I'm trying to think, a triangle. And you can do the triangle with the little shift 6, okay? And what that should do is that should plot a triangle, just like that plots a dot, that plots a solid line, that plots a dotted line. This should plot triangles that are green. So let's try. Okay, look at that. So now I have y is equal to 2x here, and then I have the other equation here. So you see I'm getting more than one plot on the same graph. What do I not like about this? I don't like it when you run right up into the corners, and so I would like to define my own scale. Okay, this is auto-scaling. You don't have to auto-scale. You can define your own scale. And so what I'm going to do is I'm going to see if I can move this down here. And wouldn't it be nice if that would just stay there and pop up there every time? And I'm sure there's a way to make it do that. I just don't know what it is at this point. So what I want to do is I want to create my own axes. So I'm going to say plot, and then I'm going to say the axis. And now what I need to do is I need to open parentheses, and now I have to open bracket, and I got to give it x min, x max, y min, y max. And so I'm going to go from 0 to 6 because I want a little space in there. I don't want to run up into the corners. And now I want to go, let's say I'm going to go minus 8 to 12. You see, I like to make my scales a little bit bigger than than just running all the way to the edge of the graph. And so the x min is 0, the x max is 6, the y min is minus 8, and the y max is 12, and then I close that bracket. So just see those four numbers need to be not only inside parentheses, but need to be inside of a bracket. So it's like an array of x min, x max, y min, y max. Let's see how this works. Okay, look at that. Just like I told it to do. Let me see if I can get this where you can see it. So we went from 0 to 6. You see 0 to 6, minus 8 to 12. And that's just a really nice little, that's a really, really, really nice little graph. I like that. Okay. Let me show you one more thing. Now this is just, I shouldn't say that because you would get confused at what it is. And so what I should say is the y label. Now it would probably make more sense to say, like call it, you know, my y values or something. Okay. Now what I want you to see is how do we tell people what is what? Okay. How do we tell people what is what? We need a legend so they know what is what. And so let's do a legend. And what I do is, let's say up here where I was plotting those blue dots for that first equation, what I need to do is I need to give that a label. Okay, and the label of that was, what was that? That was y, and I need to put it in a quote, y is equal to 2x. All right, so that gives a label to that. And let me give a label to this z one here as well, where we had that with the green. Okay, so I'm going to say label is equal to, and then what did we say that was? I think it was y is equal to minus x plus 4. And so that's going to be the label of that one. So I've now labeled those two things, and so what I could come down here and do, besides everything else, I could do plot.legend, and it should print those values somewhere on my plot so I know what is what. Oh! Okay, what did it not like? Label, what? What did I forget? I forgot my comma. And did I forget it on the other one? No, I think I got it on the other one. Okay, comma between parameters. So let's run this now. Okay, boom, boom. All right, so it's showing you between the dots because this is quite annoying. Okay. So it's saying between the dots, because that's where I did it. It was on the blue dots. I said y is equal to 2x. And so y is equal to 2x. Between the green triangles, y is equal to minus x plus 4, because that's what I labeled that one. I could have, instead, I could have put them, let me cut this. I could have put that here, and then I could have put this like that. And now let me run it. And now it should put it with the lines in the line color. And I might like that a little better. Yeah, I think I like that a little better. So it's saying the red line is y equal to 2x. The dotted green line is y is equal to minus x plus 4. Was that minus x or minus 2x? I think that might have been minus 2x. I'm sorry, I have trouble doing these things in my head. But you get the idea. You get the idea. Okay? So that is showing you how you can add the titles, add the labels, add the grid, set the axis range, just a whole lot of stuff that you can do there. But the truth is that usually you are not going to want to enter things in this way where you enter all the points. Usually you're wanting to plot a function. Okay, and so let's just try to plot the function. Oh, let's say that we want to plot the function y is equal to x squared, a quadratic. And let me show you an easier way to do it. So you wouldn't want to go in and put in a bunch of data points. You want to let Python do the hard work for you. And so I think that I'm just going to get rid of all this, and I'm going to start over. So we want to plot y is equal to x squared. So what we want to do is, instead of entering all of those x values, instead of having to go in and enter a whole bunch of x values, we want to let Python and NumPy generate those for us. So instead of coming in and saying, okay, I want the x values to be -4, -3, -2, -1. Imagine if you wanted like in 10th increments or 100th increments. That would take forever. So I want to generate the array all at once. And I do that with a command called np for numpy, numpy.arrange. So I want it to arrange the x for me. And I want to go from, let's say I want to go from -3 to 3, and then I want my step size to be 0.1, or let's say 0.25. Okay, so what I want to do is I want to create an array x, and I want to start at -3, and I want to go to 3, and I want to go in 0.25 steps. And so let's just print that to see if we generated what we thought. Print x to see if we generated that array like we thought. Okay, so let's look at this. -3, -2.75, -2.5. So you see we generated that array. All right, we generated that array. So now that we have the x array, look how easy it is. We can start doing array math, where we do the math on the whole array. So let me go back and change this. So now we have x. What do we want? Y. Y was equal to x squared. So the way you do squared is it's star star, shift 8, shift 8. That's to the power. So that's x to the power of 2. And so now I have a y array, and that y array is the x array squared, each element squared. And to make it easier, I'm going to say start at -3, go to 3 in steps of 1. Okay, so and then what I want to do here is I want to print x, I want to print y. And I'm just showing you how to generate arrays here. So let's run this. Okay, and look at that. X is -3, -2, -1, 0, 1, 2, and -3 squared is 9, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, and then 2 squared is 4. Okay, so there we have it. So I was able to generate the X array, and I was able to generate the Y array. And these prints I put in there just so that you could see them. What do we really want to do? We don't want to print them, we want to plot them. And so now let's plot, and plt.plot, and then what do we want to do? I want to plot x, I want to plot y, and now what would I like here? I think I would like blue, and I think I would like dots, and so blue, dots, and then I think I would also like a line. And then I'm going to say, I'm going to go ahead and put a label, and the label is going to be equal to, oh, what would we call this? Y is equal to x, and I'll use that little shortcut, x squared. And so I have a label on that in case we want to do something later. And then I'm going to say plot legend, and so I tell it to show the legend, and then plot title. Where are we going to put the title? My quadratic. Okay, and then what we're going to do is plot x label is equal to, is going to be my x values, and then plt.y label is equal to, not equal to, just y label is my y values. And then we want to do plot.show. Let's see how many mistakes I made. Ooh, legend. That should be legend. Why didn't somebody yell at me when I did that? Okay, let's try it. All right, look at that. Look at that. So I've got my quadratic here that I plotted. Okay, it's kind of jumpy, right? I mean, it's kind of like, it's kind of kludgy. We need more points than that. So when we came up here and we generated the NP arrange, when we generated the X array by saying arrange the numbers between -3 to 3 in steps of 1, let's go back and put that at 0.1, and then we should get lots of dots. Okay? All right. Look at that. That looks pretty good. That is a nice looking quadratic. We have our legend, y is equal to x squared, my quadratic, my y values, my x values. That is pretty nice. Let me show you one thing that I don't like about this. Notice how it always stops before it gets to this value. So if I want to go from -3 to 3, it stops at -2.9. And if I go back to 1, I think you can see, so I say go from -3 to 3, it'll go up to 3, but it doesn't do 3. It always drops that endpoint. Okay, so you see when I said to go from -3 to 3, it stops at the number before 3. It's just the way the NP arrange command works. So it goes from -3, -2, -1, 0, 1, 2, and then it stops at the number before 3. And that annoys me. So what I guess I could do is I guess I could say go from -3 to 4, knowing that it does that. And then when I do that, it will go all the way to 3 because it stops 1 before 4. All right. There is a different way of doing this. So the NP arrange, the way this goes is it goes from the start value to the stop value and the increment, and then it always stops the one before, the one before the stop value. I don't like that. There's another NP way, NumPy way to make an array, and instead of arrange, it's called line, L-I-N-S-P-A-C-E for linear space. And the way this works is it's the start value, the stop value, and the number of points. I should say number of points. I mean, I've got to go in and put these things, but this just shows you how it is. So this will go from the start value to the stop value, and it really goes to the stop value and then the number of points. And so let's see. I want to go from -3, and I want to go to 3. And then how many points do I want? I want 10 points. And so now let me run that. Oh yeah, okay. So you see, what that did was it went all the way from -3 all the way to 3, and it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think that's kind of goofy to flatten that end, and so if you have a quadratic, it might make more sense to make that an odd number so that you don't end up with a flat spot on there. Yeah. So you see that way it comes down and has one in the middle there. Or what you could do is you could put a whole bunch of points. What if you said 100 points? All right, so go from -3 to 3 and have 100 points. I think I'll like that. All right, and then that looks pretty good. The one thing maybe at that point, maybe you don't want to do your dots. Maybe you just want to make it just a line at that point. So you say blue, take the dot out, and just make it a line like that. Run. Okay. Now that is a pretty darn smooth quadratic. Okay. So you don't, I mean, you're not limited to just doing something like y is equal to x squared. You could plot anything. What if we wanted to, what if we wanted to sort of start getting fancy here? And let me just kind of show you. You see, like let's sort of start playing with what happens with quadratics. So let's say my math teacher keeps coming out in me. When I start seeing this plot, I start thinking about my life as a math teacher. And so I have y is equal to x squared. What if I say z is equal to, okay, x minus 2 squared? When I subtract 2 from x, what is that going to do? Well, I need to plot z out, and so what I'm going to do is I'll plot x and z. Okay, and this time it's I'm plotting x and y. Here I will plot x and z, and instead of a blue line, I will plot a red line. And this was I'll change the label so I'll know what it is here. Say -2. And then squared. All right. So now I should plot two quadratics, and let's look at what happens. Yeah, I get two quadratics, but you know what I don't like is that's okay. That's okay. So what happened? I started with the blue, and that's x squared. If I say x minus 2 squared, what does it do? It moves the curve to the right. So saying x minus 2 moves the curve to the right. Well, what if I say x plus 2? What's that going to do? That moved the curve to the left. So it's sort of like if I put plus 2, it moves it to the left, If I say minus 2, it moves it to the right. It's almost like the curve is moving the opposite direction of what you're doing to x. So that's kind of interesting. I'm just going kind of crazy here, and so I have got to turn my grid back on. So I'm going to say plot.grid, and I'm going to say true. And then I'm going to go from -5. I'm going to go from -5 to 5. And then I guess I will still let it auto range. So let's try that. I want to see a bigger range. Yeah, okay, so that's looking better. So whatever I do to the x value, it sort of moves the curve in the opposite direction. If I make x plus 2, it moves it to the left. If I make it x plus 3, x minus 2, it moves it to the right, and so it sort of moves it the opposite direction. Well, what if instead of messing with x, what if I said that this was x squared, and now outside here I said plus 3. What's that going to do? Look at that. That moved it up 3. Okay, so if I add a number outside, not beside the x, it moves it in the same way. If I say plus 3, it moves it up 3. If I say plus 7, it moves it up 7. If I say minus 3, it moves it down 3. Minus 5, it moves it down 5. But when I put it in here with the x, it moves it in the opposite direction of the sign. So you see, you can sit here and you can start playing with these things, and you can really learn quite a bit. Let's do another one. Okay, this time I want to go from, let's say, 0 to 2 pi, and so I'm going to use my NP line space. So I'm going to create an x array, and I want that x array to start at 0, and I want to go to 2 pi. So that's 2 times, I could type 3.14, but I could just get pi by saying np.pi, and it will know what that is, and then I want 100 steps. And so that's x, and now what is y going to be? I want y to be np.sine, and I want y to be the sine of x. Okay? And at this point, I need to take some of these things out. And here y is equal to sine of x. All right. So now let me run that. Is it really that easy to make a sine wave? Look at that. It is really that easy to generate a sine wave. I cannot stand this because I don't like it running into the edge of the graph. And so I'm going to come in and put my range in. So I'm going to say plot.axis. And I'm going to go from 0 for x min. What was my x max? It was 2 times np.pi. That's just a way to get pi real easy. And then y min, I want to go from minus 1.5 to y max 1.5. Close the square brackets. Close those brackets. Now let's run it. Okay. Isn't that neat? That is really neat. Because I have y is equal to sine x. Well, what else would be neat? It'd be even neater to do cosine x. So I have the x array goes from 0 to 2 pi with 100 steps. Y array is the np.sine. That's how you take the sine of a whole array. So you got the whole array x. Y is a new array that's the sine of x. And so let's do a z, which is going to be equal to np.cosine of x. And then I want to plot that as well. So I'm going to take this, copy it, paste it, and this time instead of x and y, I want to plot x and z, and I want to make it red just because I can. And then what I want is I need to tell it that label it right. So this is just the label here, but we want to get the label. We want to get the label right. So now let's run that and see what happens. Look at that. I made the sine wave and I made the cosine wave. And I think that is just really, really, really neat. And I guess I should have been updating my things along here. That's no longer the right title. But you get the idea. You can see with just some real simple commands how you can make plots. You want to create an x array. you want to create a y array, and then you want to do a plt.plot of x and y, and then just sort of give some parameters. I can't help it. I want to put dots. I have this urge to put dots. I have to put dots on there. Let's go. There are my dots. I think when I have dots, I need to have fewer points. So let's see if, what if I made it like 25? Can you get a good sine curve with 25? Let's see. Beautiful, beautiful, beautiful. Look at that. That's my sine. That's my cosine. And so you have just got a really, really powerful tool here. This is really great to use in math class. Like if you think of all those graphing things you have to do, go in there and do your graphing with this, and you can see that you could probably impress your teacher with some really nice graphs. Ask them beforehand to make sure it's okay for you to use a computer to write a, ask them if you can write a computer program to do the graphing and sort of explain it, because it just gives you so much more flexibility, and you're not just sitting there fighting with the calculator in your little tables and trying to draw things with a ruler. You can actually get the program up the computer to graph these things for you. Okay, I think that is a pretty cool introduction to Matplotlib. It's here we're just plotting arrays that we're creating. The next thing that we're going to do is, instead of making up these arrays, we're going to be getting those arrays coming in off of the serial port from the Arduino. And so that will be the next lesson. Okay, appreciate you guys tuning in. Think about subscribing to my channel. We're going to continue to move forward with this, and we'll be getting back to some pretty exciting Arduino projects that will be feeding data to Python, and then we will be plotting it live coming up in the next few lessons. Take it easy, guys.